दिस इज बेसिकली ब्लॉक डायग्राम। यू ब्लॉक डायग्राम कहें या कहें कि आर्किटेक्चर ऑफ दिस 8085 8085 वॉट एवर वी कॉल इट माइक्रोप्रोसेसर, इसका ये ब्लॉक डायग्राम कहें चाहे आर्किटेक्चर कहें। तो इसमें अगर तुम देखोगे तो जो ये सब चीजें यहाँ पे ऐसे ऐसे लिखी थी, वही सब चीजें यहाँ भी कहीं ना कहीं कुछ ना कुछ फॉर्म में लिखी हैं। सो यू सी AD7 to AD0, this is address bus, data bus. So you see here कहीं पे है ना 8 AD0 to AD7, so all this are what address bus का हम लोग यहाँ पे डेटा देते हैं। Then you see 815 to 88 to A8 to A15, this is address bus। ये क्या है, ये भी कहीं पे होंगे, ये देखो A15 18 तो उसमें नहीं है, यहाँ पे 8 to 15, हाँ A8 this to 15, this is again address bus। so address bus क्या है, इन जनरल हम लोगों ने बात की है। एड्रेस बस वो होता है जिसमें हम कुछ कोड देते हैं और वो एड्रेस डिकोडर से कोड करके बताता है कि ये कहाँ पे जाना है। जैसे इफ यू रिमेम्बर इन प्रीवियस क्लास we are talking about this is address register, here we give something, then this is about read and write operation। so this is read operation, यहाँ पे हमने कुछ ऐसे दिया, एड्रेस बस के थ्रू यहाँ आया, दिस इज एड्रेस डिकोडर, उसने इसको डिकोड किया एंड से वी आर टॉकिंग अबाउट जो मेमोरी मेमोरी रे है उसमें हम लोग इसकी बात कर रहे हैं। फ्रॉम दिस नंबर, फ्रॉम दिस डेटा वी केम टू नो वी आर टॉकिंग अबाउट दिस पार्ट ऑफ दिस। फिर डेटा रजिस्टर में कुछ बोला और उसको उसने रीड किया एंड इट रीड दिस डाटा एंड इट वेंट देयर। फिर रीड ऑपरेशन में हम लोग देख रहे थे, तो यहाँ पे देखो एड्रेस बस का क्या रोल है। Similarly here when we are talking about this part, so it is bit complex and we are like a most advanced thing of our course। हम लोग जो कोर्स पढ़ रहे हैं डिजिटल इलेक्ट्रॉनिक्स का, उसका सबसे कॉम्प्लिकेटेड सबसे एडवांस टॉपिक हम लोग अभी डिस्कस कर रहे हैं। इसके पहले हम लोग बहुत फंडामेंटल चीजें पढ़ रहे थे। सो दिस इज एड्रेस बस। एड्रेस बस में हम कुछ डेटा देते हैं जिसके थ्रू वो एड्रेस करता है। देन यू सी दिस इज समथिंग सीरियल इनपुट आउटपुट कंट्रोल, दिस इज इंटरप्शन कंट्रोल, दिस 8-bit internal data bus। okay, this is accumulator, this is temporary register, this is flag flip flop, instruction decoder and machine cycle encoding, this is instruction register, this is same thing, this and this। and then जो हम लोग बोले थे पेयर में रजिस्टर्स है, so you see B C D E H L, these are registers, and this is stack pointer, this is program counter, this is address latch, this register area। तो most of things you see there are a lot of registers। तो हम लोगों ने जब बहुत पहले अभी एक बहुत जनरल पिक्चर देखा था, you say these are register files, this is control unit, this is ALU, and then you see this 8085 तो क्या है, so this is timing and control thing, this is register array, this is interrupt control, और यहाँ पे बहुत कुछ हो रहा है, इंस्ट्रक्शन डिकोडर एंड मशीन साइकिल इनकोडिंग, इंस्ट्रक्शन डिकोडर एंड मशीन साइकिल इनकोडिंग, दिस इज एड्रेस बफर। सो ये सब का हम लोग कोशिश करेंगे समझने का कि जो भी एक एक चीजें हैं इनका क्या मतलब है और ये सब कैसे काम करते हैं। तो इन जनरल वी विल ट्राई टू एड्रेस ऑल दिस बॉक्सेस, इन पे हम लोग थोड़ा बहुत बात करने का कोशिश करेंगे, ओवरऑल समझने का कोशिश करेंगे। लेकिन आई होप अप टू नाउ लाइक वी स्टार्टेड टुडे दिस माइक्रो प्रोसेसर थिंग, इतना पढ़ के कुछ ये समझ में जरूर आएगा कि माइक्रो प्रोसेसर कैसे होता है, क्या क्या उसके एप्लीकेशन होते हैं, And how does it work? This is the most advanced thing in our course, and we are trying to understand microprocessor in 2 or 3 classes. So in that way, we can't go much greater detail, but एक जनरल आइडिया आएगा और उसको उसको समझ के हम लोग जब आगे कुछ हायर क्लासेस पढ़ना होगा या इफ यू नीड सम टाइम टू अंडरस्टैंड माइक्रो प्रोसेसर then you will have a detailed course in masters or anything you want to pursue where if it is important you will have that greater detail, but for our scope of our course we will try to address. Basically, we will try to understand how does it work and what are its basic major components and how it perform things. So we will be spending some time over this block diagram to understand the different part of this. और कई सारा मटेरियल कई सारा लेक्चर नोट के फॉर्म में या बुक्स में ऐसे डिटेल में बहुत कुछ है, लेकिन हम लोग अपनी जरूरत भर की चीजों को यहाँ पे लाएंगे एंड विल ट्राई टू अंडरस्टैंड ऑल पार्ट ऑफ इट. सो यू सी हम लोग को पढ़ना क्या है. 8085 माइक्रो प्रोसेसर आर्किटेक्चर पढ़नी है. तो ये हमको क्यों पढ़ाया जा रहा है? क्योंकि हम लोग ये सब समझ पाए कि ये बसेस क्या होती है, रजिस्टर क्या होते हैं, एलयू क्या है, मेमोरी क्या है, स्टैक मेमोरी क्या है, टाइमिंग एंड कंट्रोल सर्किटरी, what does it mean? So this is in our syllabus. Main features of 8085 block diagram. Today we will be going into the detail with more profound way to better understand what are these blocks are and what role they play in this. So we see these are some basic components, basic numbers to identify this 8085 microprocessor. It is an 8-bit microprocessor. It is 40-pin IC fabricated on single LSI chip. LSI means larger scale integration. And it uses 5-volt power supply for its operation. Its clock speed is about 3 megahertz. Clock cycle is 320 nanosecond. These are some basic details. It has 80 basic instructions and 246 operation codes. And as usual, as we talked about when we talked about general microprocessor, then also we told it has 3 main sections. One arithmetic and logic unit, timing and control unit, and several registers. So what this arithmetic logic unit does, these are some basic operations it performs in order to the instructions to be given on for microprocessor to process. So these are some arithmetic and logic operation. ALU performs addition, subtraction, logical and logical OR. These are the operations basically, and we know this AND gate and OR gate, what operation they perform. All this is being conducted by ALU. This unit is responsible for conducting all these operations. Logical exclusive OR means XOR, that XOR gate we studied. Complement, logical NOT gate. Increment, decrement, left shift means add input to itself. Clear, all these operations are performed by arithmetic logic unit in a microprocessor. And then second thing is timing and control unit, what it does. And the timing and control unit is a section of CPU. It generates timing and control signals which are necessary for execution of instructions. It provides status, control, and timing signals which are required for the operation of memory and input-output devices connected to microprocessor. It controls the entire operation of microprocessors and the peripheral consented to it. Peripheral consented means the input-output devices which are connected to microprocessor for its for the commands what we give to be executed. So it is seen that control unit of CPU acts as a brain of the computer, and this timing and control unit is part of CPU. So in general, we are trying to discuss the different units and what they are supposed to do. As we talked about ALU, what the operations it performs, and then this timing and control unit, what it does, it generates timing and control signals. And that are very necessary for execution of instructions which we want to do it through microprocessor. And then third thing comes in this third component, main component of microprocessors is registers. So there are many type of registers, and registers basically we have talked previously when we discussed shift registers. We talked that it works as a data storage and data transfer. So similarly here also there are different registers. Registers means this is a combination of flip-flops. It used to store data, it used to process, it used to transfer, shift, and there are a lot of these operations conducted using registers. So registers are a small memory within CPU. So since registers are made of flip-flops, and one flip-flop can store 1 bit of information, so in general we can say they are small memories. They are used by microprocessor for temporary storage and manipulation of data instruction. So we have also talked about different type of memories where we discuss RAM and ROM. So basically there are two type of storage. One is temporary, one is permanent. Temporary storage is like something in general we say when we conduct some transaction we use OTP kind of thing. So OTP is not useful later on once you use the number. So similarly there are some operations, there is some instructions which are not necessary to be stored all the time. They are needed for some particular operation, some particular manipulation of data. So for that we use registers. So data remain in the register till they are sent to the memory or input-output devices. In a large computer, the number of registers is more, and hence the program requires less transfer of data and from the memory. In a small computer, the number of registers is small due to limited size of the chip. And when we talk about this particular 8085 Intel microprocessor, it has following registers. So one 8-bit accumulator, that is register A. Where is register A? If you go back to this, you see this is accumulator. So this is register A basically. And then when we talk about the 6 8-bit general purpose registers, these are B, C, D, E, H, L. So let us go back to this architecture of this. So see, these are general purpose registers. They are in pair. See, B, C, D, E, H, L. These are these registers. And then one 16-bit program counter pre-C. Let us see where it is in this. So this is program counter. You see, these all are basically registers. They have some defined set of work to be performed, which we give some data for data processing, data manipulation. So all these for all these purposes we use these registers. Then instruction register, where is that? So this is instruction register. You see instruction register, and then status register and temporary register. Where is that? A status register and temporary register. So this is temporary register, and status register किसको कह रहे हैं? So probably this flag flip-flop instruction decoder and machine cycling encoding. This is done by this. So these are different type of registers. They are used for data manipulation, data transfer, data storage, different kind of purposes. Then in addition to above mentioned register, also contain address buffer and data address buffer. So these are this address buffer. So these are basically, you see, there are different type of registers. Mainly a lot of registers you can see there on this microprocessor. So you see this A15, A8 to A15, then 80 to 87, these all are address buses, addresses, data bus, whatever we call it. And you see here all these pin. This microprocessor is fabricated on a single chip. This is 40 pin IC, and you can see all these are address buses. Then we will try to talk on different registers and what are its role, what they do in a very specified manner. We are not going in the very great detail of its programming, its execution. We are just trying to touch its architecture and trying to explain all the different boxes where we put in this diagram where we talk about the internal structure by looking at block diagram. So the program counter, what it does, it contains the address of the next instruction. The CPU fetches an instruction from the memory, executes it, and increment the content of the program counter. Thus the next instruction cycle, it will fetch next instruction. Instructions are executed sequentially unless an instruction changes the content of the program counter. So the instruction register holds the instruction until it is decoded. This cannot be accessed by programmer. So this is what program counter does. Basically, it takes instructions, and when one instruction is processed, decoded, then it takes next instruction. So it is a kind of sequential circuit. Sequential circuits हम लोग समझते हैं जहाँ भी ये फ्लिप फ्लॉप वगैरह आता है, it is a sequential circuit since flip flop is a memory element. So in a way we can say this sequential circuit, the sequence is important. That is why it is written the instructions are executed sequentially unless an instruction changes the content of the program counter. So this is how it takes instruction. Then what is this stack pointer? Stack pointer, let me show you where is this. This is a stack pointer. This is program counter. We just talked about program counter. Now we're talking about what is this stack pointer does in this 8085 microprocessor. So the stack pointer holds the address of the stack top. The stack is a sequence of memory locations defined by the programmer. The stack is used to save the content of a register during the execution of the program. The last memory location of the occupied portion of the stack is called stack top. So, in general, we can understand what it does. It holds the address of the stack top. Stack top क्या है? Last memory location occupied portion. Last memory location of the occupied portion of the stack is called a stack top, and the stack pointer stack top का जो एड्रेस है उसको रखता है तब तक. And the stack क्या है? It is a sequence of memory location defined by the programmer. हम जैसे हमने कहा कि मेमोरी होता है तो उसको हमको एक एड्रेस मेमोरी एंड मेमोरी के साथ उसका एड्रेस एंड व्हेनेवर वी वांट टू एड्रेस इट एक्सेस दिस मेमोरी लोकेशन we have to give this it in address decoder and all. So this is what the stack pointer does in this microprocessor. And then there are 6 8-bit registers. So those we were talking about, just these registers you see. Okay. So what they does, there are 8-bit. There are six 8-bit registers. रजिस्टर का 8-bit रजिस्टर होगा तो उसमें कितने फ्लिप फ्लॉप होंगे? Basically 8 flip flops होंगे. And one flip flop can store 1 bit of information. So there are 6 8-bit registers. What they do, they are used for general purpose as desired by the programmer. Programmer मतलब जो भी इसको बना रहे हैं, हम अलग अलग एप्लीकेशन करते हैं इस माइक्रो प्रोसेसर को अलग अलग जगह लगाते हैं. So depending upon where we are using it, so we can use these registers for general purpose. These 8-bit registers are A, B, C, D, E, H, L. These are the names. To handle 16-bit data, two 8-bit registers can be combined. अगर हमको 16-bit data handle करना है तो हम इसमें से दो को एक साथ कंबाइन कर लेंगे. तो since one is 8-bit register, so if two are combined, then it can form 16-bit data. So the combination of two 8-bit registers is called register pair. The valid register pair in Intel 8085 are B, C, D, E, and H. So B, C, D, E, H, L, you see, you can see they looks like they are in pair. The B, C, this can be used as a pair. And this is D, E, and then H, L. And they are general purpose registers. So the HL pair is used to address memories. And the register A is accumulator. जो हम लोगों ने इधर साइड में देखा एक रजिस्टर है उसके एक बॉक्स है जिसमें accumulator लिखा है. This is a register, and this register A is an accumulator, and it is for temporary storage used during the execution to a program. It holds one of the operands. The other operand may be either in the memory or in one of the registers. In general, we can say what these 6 register does, and then there are a set of 5 flip-flops which act as a status flag. So we were talking about this flag register, this flip-flop. तो ये इसमें 5 flip-flop हैं, flag flip-flop जिसको बोलते हैं. And what it does, you see, it is connected to this instruction decoder and machine encoding. Does this work? And the double arrow, whenever you see, this is bidirectional, means this 8-bit internal data bus hai, this is connected to all this and data can come from here, it can go from here. So data bus, this is a bidirectional data bus. This is symbol 4. So data can come from here to here, and can go here to here, and how all this is connected. You see this accumulator is connected to this. What data it gets, it sends to the decoder and machine cycling, decoding and encoding thing happen here. And this again, this temporary registers and flags are also connected to it, and then this again connected to this 8-bit data bus. So you see this is an internal data bus, and most of things are connected to this. A single arrow means data from instruction register cannot go to this. It will from internal data bus, it will come to instruction register, then instruction register to instruction register. इंस्ट्रक्शन रजिस्टर जैसे हम लोगों ने पहले बात किया है, क्या करता है, एक एक इंस्ट्रक्शन को स्टोर करता है, and when then one instruction gets encoded and it goes to timing and control unit, then it takes next one and next comes in. So this happens like this. So again, there are set of these 5 flip-flop which act as a status flag. Each of these flip-flop hold 1-bit flag indicates certain conditions which arise during arithmetic and logic operations. The following status flag have been provided in Intel 8085. तो जो 5 हैं, इनके ऐसे नाम है, इनके बारे में भी कुछ डिटेल दिया है, बट आई थिंक बहुत सारा डिटेल में जाने से कुछ मतलब नहीं है, and I don't see that a lot of people are interested to learn in that way. So हम लोग उतना ही पढ़ना है जितना हमको जिससे हमारा काम चल जाए और हमारे जरूरत भर का पढ़ाई हो. मतलब we are not going beyond the scope of our course. So this carry, zero, sign, parity, auxiliary carry. So I have some one file where it is in 58 pages long, and a lot of information is there. So if anybody is interested, I will share that file also. Then we talk about data and address bus. So the Intel 8085 is an 8-bit microprocessor. The data bus is 8-bit wide, and hence 8 bits of data can be transferred in parallel from or through the microprocessor. So you see this data bus. If we go on there, most of things we have to go on this picture. So this is 8-bit internal data bus. It means 8-bit information it can forward parallelly. जैसे जो हम लोग बात करते हैं, कभी कभी कुछ डिवाइसेस हैं उसमें डेटा कितना फास्ट प्रोसेस हो रहा है, डेटा ट्रांसफर का स्पीड, ये सब तो इस पे डिपेंड करता है कि हमारा जो एड्रेस बस है, डेटा बस है, वो उसमें कैसे स्पीड है और मतलब कितने बिट इंफॉर्मेशन वो प्रोसेस कर सकता है. तो इसको हमको देखना होता है. डिपेंडिंग अपॉन डेटा बस किस तरह का है, कितना पैरेलल बिट इंफॉर्मेशन इट कैन प्रोसेस, so that comes data transfer speed and all is decided by this. अगर हम लोग इसको 1 बिट होगा तो हम 8 बिट इंफॉर्मेशन प्रोसेस होने के लिए जो उतना ज्यादा टाइम लगेगा, जितना पैरेलल डेटा ट्रांसफर हो सकता है उतना ही स्पीड आता है. जो भी हम स्पीड का बात करते हैं, दिस प्रोसेस बेसिकली दिस डेटा ट्रांसफर डेटा बस हमारा कैसे है, it is decided by that. So a bit of data can be transmitted in parallel from R2. From R2 मतलब दोनों bidirectional to the microprocessor. The Intel 8085 requires a 16-bit. So the 8 most significant bit of address are transmitted by address bus. These pin A8 to A85 ये में क्या करता है? Most significant जो bits है. Least significant, most significant. You know from the binary numbers कैसे किसको हम लोग most significant बोलते हैं, किसको least significant बोलते हैं. The most significant bits of address are transmitted by the address bus pin A8 to A15. and the 8 least significant bit of the address are transmitted by address data bus, which is this pin AD0 to 87. So both are 8, 16 pin are there. This is how we can transfer data. The address data bus transmits data and address at different moments. At a particular moment, it transmits either data or address. तो डेटा ट्रांसफर एड्रेस ट्रांसफर देर आर मतलब जैसे हम लोगों ने शुरू में एड्रेस बस डेटा बस देखा तो इनडायरेक्टली सब जगह वही बाइनरी नंबर ही है. दिस आर ऑल बाइनरी कोडेड एवरीथिंग व्हाटएवर यू कॉल एड्रेस. एड्रेस कमांड दे रहे कुछ भी दे रहे हमको बिना बाइनरी के काम नहीं चलेगा. Everything converts into binary numbers with using a decoder, encoder. So some command is there, it's converted into binary numbers, and then it goes with the address bus. So address bus, data bus, basically there are not much difference. All they process binary data, but basically वो coding decoding करके हम किससे क्या कर रहे हैं. This is why this address slash data bus transmits data and address at different moments. At a particular moment, it transfer either data or address. तो एक बार में एक ही चीज करेगा. Thus, AD bus operates in time shared mode, and this technique is known as multiplexing. First, first of the all 16 memory addresses transmitted by the microprocessor, the 8 most significant bits of the address on a bus. So we were talking about first of all 16-bit memory address is transmitted by the microprocessor. The 8 most significant bits of the address on the A bus and 8 least significant bits on AD bus. तो जो हमने AD और ये यहाँ पे बात किया है उसमें बोल रहे हैं कि ऐसे डेटा ट्रांसफर होता है. And the 8-bit AD bus now becomes free. जब ये हो गया मतलब effective width of address is less to that complete 16-bit address remains available for further operation. एक तरह से ये समझा रहे हैं कि 16 बिट का जब प्रोसेसिंग करना है तो कैसे होता है. तो ये बिट 8 सिग्निफिकेंट बिट को हम लोग इस बस से ट्रांसफर करते हैं एंड अदर्स 8 लिस्ट सिग्निफिकेंट बिट्स है उनको हम इस बस से ट्रांसफर करते हैं. So the 8-bit AD bus now becomes free and it is available for data transfer. So 2 to the power 16 bit data transfer कर रहे हैं तो 2 to the power 16 memory locations can be addressed directly by Intel 8085. So you understand there are this we talked about this is 16 bit memory address अगर हम ट्रांसफर कर रहे हैं तो इतनी मेमोरी लोकेशंस को हम लोग एक बार में एड्रेस कर सकते हैं. Each memory location contains 1 bit of data. Then this other thing is the timing and control signal. So what it does हम लोग इसके बारे में थोड़ा सा बात किए थे. थोड़ा सा और इसको पढ़ते हैं और इतने ही पढ़ के हम लोग अपना काम चलाएंगे. The timing and control unit generates a timing signals for the execution of instructions and control of peripheral devices. This is what in general timing control unit does. And तो ये इसके लिए ऐसे सिग्नल जनरेट करता है जिसमें हम लोग जो इंस्ट्रक्शंस और कंट्रोल है वो हम उसको प्रोसेस कर सकते हैं. The organization of microprocessor and types of register differ from processor to processor. ये जो है जैसे हम लोग 8085 पढ़ रहे हैं ऐसे ही अलग अलग माइक्रो प्रोसेसर के लिए अलग अलग तरह का ऑर्गेनाइजेशन हो सकता है. तो ये जो हम लोग अभी देख रहे हैं इट इज पर्टिकुलरली फॉर 8085. दिस इज इन आवर सिलेबस. सो देयर आर मेनी डिफरेंट टाइप्स एंड देयर आर डिफरेंट टाइप ऑफ ऑर्गेनाइजेशन देयर. द टाइमिंग यूज्ड for the execution of instructions and control of peripheral is different for different microprocessors. The selection of suitable microprocessor for a particular application is a tough task for engineer. कौन सा microprocessor use करें ये बोल रहे हैं कि this is a tough task. The knowledge of the organization and timing and control system helps an engineer in a selection of microprocessor. The design and cost of microprocessor also depend on the timing structure and register organization. So there are three things in general: this ALU, timing and control unit, and registers. So the person who is expert on that, uh, he knows about details of different available microprocessors and the kind of work we are looking forward to do. And then these are some general applications. माइक्रोप्रोसेसर कहाँ कहाँ यूज होते हैं, हम लोगों ने कुछ बात किया था इसका 8085 का, फिर मैंने देखा कि ये इसमें कुछ ज्यादा एप्लीकेशन के बारे में बात कर रहा है, so I kept it there. So microprocessors are being used for numerous applications, और कुछ एप्लीकेशन के बारे में यहाँ से लिखा हुआ है कि कहाँ कहाँ माइक्रोप्रोसेसर यूज होता है. So पर्सनल कंप्यूटर्स, जो हम लोग कंप्यूटर्स यूज कर रहे हैं, लैपटॉप यूज कर रहे हैं, सब में माइक्रोप्रोसेसर है. दिस इज हाउ इट परफॉर्म ऑल द एग्जीक्यूशन जो भी हम कुछ देते हैं. एंड इन मोबाइल फोन्स, ऑटोमोबाइल्स यू सी नाउअडेज कैसे कैसे ड्राइवरलेस कार और सब कुछ आ रहा है. तो दिस इज ऑल बिहाइंड द सीन. ये सारा प्रोग्रामिंग ऐसे हो रहा है कि इट बिकम सेंसिटिव टू द सिग्नल्स एंड देन इट controls according to the instructions given on this. Vending machine, medical diagnostic equipment, automatic voice recognizing system, traffic light control, games. बहुत सारे गेम्स हम लोग जब खेलते हैं ये सब भी कहीं ना कहीं. Digital signal processing, communication terminal, process control, calculators, telecommunication switch system, automatic test system. All their places the microprocessors are used, and different type of microprocessors are available in the market, and it is a task of an engineer to select a particular microprocessor for a particular task. तो हम लोग को बेसिकली थोड़ा ही समझना है माइक्रोप्रोसेसर के बारे में. हम लोगों ने बेसिकली जो ये कोर्स पढ़ा, अगर तुम देखो जब इसमें मेन पिक्चर ये है, यहाँ पे हम चीजों को देखते हैं. So if you understand something, so you see somewhere we have studied things throughout the course, and in general we see the most involved application of what we have learned in this course.